Hi guys, in this tutorial I'm going to solve question number 6, paper 42 March 2020. On a straight horizontal test track, driverless vehicles, this means with no passengers, are being tested. A car of mass 1600. We have a car. Its mass is 1600 kilogram, towed with a trailer. So the connected two particles. This is the car, name it C, and the trailer is G. Mass is 700 kilogram. The brakes are applied, resulting in deceleration 12. This is the deceleration. The braking force act on the car only. In addition to the braking force are their constant resistance. Resistance of the car is 600. Resistance of the trailer is 200. Find the magnitude of the force in the toy bar. We can start to write equation of car or equation of trailer or equation of the system. But it's clear now I need only tension. So if we try to write the equation of the trailer, all the forces in direction of motion, which is T, minus frictional force or resistance of the trailer is equal to MA. So the tension minus resistance is 200 is equal to mass is 700 and the deceleration, which is negative 12. So tension is equal to 700 times negative 12 plus 200. Calculate the value, but I need only the magnitude. So it's a direction. Now it's clear will be negative. So 700 times negative 12 plus 200. So the answer will be 8200. It's negative, but I need only the magnitude, which is 8200 Newton. This is part A. Part B, he asked to find the braking force. If I write the equation of the car, all the force in direction of motion is driving force. But in this case, we'll write driving force is equal to 0 because he started to use the brake. This means disconnected the power. Driving force minus tension, minus resistance of the car, minus using brake force, name it friction force, is equal to mass times acceleration. Driving force is 0. Minus tension found is negative 8200. This is direction. Minus resistance of the car is 600. Minus frictional force is equal mass of the car 1600. And acceleration is negative 12. By solving this equation, we can get the frictional force. It's 8200 minus 600 plus 1600 times 12. So the braking force 8200 minus 600 plus 1600 times 12. So the answer will be 26800. In part C, at the instant when the brakes are applied, the car has speed 22. At the same instant, the car is 17.5 meters away from the stationary van, which is directly in front of the car. Show that the car hit the van with speed 8. Now, initial velocity is 22. The displacement is 17.5. This is S. And the acceleration is equal to negative 12. So we need to get the final velocity. We don't have time, so v squared is equal to u squared plus 2as. The final velocity, initial velocity, is 22 squared plus 2 times acceleration is negative 12 times the displacement is 17.5. By simplifying, and you will get v squared is equal 64 by taking the square root, so you will get your answer is 8 meters per second. This is why he asked to show that. That's it. Part D, after the collision, the van started to move with speed 5. The van, its initial velocity is 0, but its final is 5 in that direction. If I use it positive, so it will be positive. And the car and the trailer, they hit it when initial velocity is 8. This is in part C. And final velocity, it's given after the collision, moving in the same direction with the speed to same direction. So all are positive. You write M1, U1, this is for car and van, a car and the trailer, M2, U2, M2, U2. This is for the van, is equal to, after the collision, M1, V1 plus M2, V2. Car and trailer together, it's a mass 2300. Initial velocity is 8. Mass 2 is not given, but its initial velocity is 0. It was rest stationary. M1 2300 times velocity of the system will be 2 plus mass is not given, velocity of van is 5. So you can solve this equation to get the mass of the van will be 2760 kilogram. That's it. Thank you.